Hello friends, welcome to VK lectures. In this lecture we are discussing the 17th and the 18th question from Kset 2018 physics question paper.
So phase-space trajectory of a one-dimensional simple harmonic oscillator. So this is the potential of simple harmonic oscillator, and this is x along x. Now a particle in this simple harmonic oscillator potential will behave like this. At here it will have zero potential or zero velocity here. As it comes down, it will have maximum velocity at this point. Again it goes to the maximum height and reaches a maximum point. Again then come. So this particle will be always within this potential. Okay, now the wave function will be something like this. All right, wave function of particle in simple harmonic potential. All right, so that is it. Now question is phase-space trajectory. What do you mean by phase-space trajectory? The px, since it is only on one dimension, you can write the momentum along x direction and the x direction here. What happens when you increase the distance? That means from this point, when you increase to this point, what happens? Your momentum will be towards this direction, right? Momentum will be towards this direction. That means if you pull this to the right side of x, that means in the positive direction of x, momentum will be towards the negative direction, right? So momentum is towards negative direction. Now as you move to the left side, so it keeps rotating. It follows a trajectory of ellipse. So when you have 0, when x equal to 0, your momentum has maximum value, right? When x equal to 0, this is the point where x equal to 0. It comes at 2 points. Either it has maximum momentum, that let me write it as plus px, and this is minus px. Now you have minimum momentum. Minimum momentum means velocity equal to 0. Where is velocity equal to 0? At these 2 points. These 2 points, 192, you have momentum equal to 0. Momentum equal to 0 means what? Momentum equal to 0 means at this point. These 2 points, 1, 2, they have least momentum. That where does it have? When momentum equal to 0, x equal to extremum. X is being extended to extremum. At that point you have minimum moment, that is 0. So phase-space trajectory means it is coordinates of, or it's a graph between, plot between px and x. Lagrangian equation of motion remain unchanged. See, Lagrangian equation of motion will remain unchanged if Lagrangian L is replaced by L plus L dash, where L is total time derivative of a function, and that function is a function of q, p and t. qp and t. qp is nothing but generalized coordinates, and this is time as it is. Now L dash is written as total time derivative d by dt of f. Okay, so your option generalized coordinates and time option, this is it. Now if L plus L is equal to L plus L dash, then what does not change? Lagrangian equation does not change. Lagrangian equation do not change. Do not change. Now what is that? This question can also be written as invariance of Lagrangian. This is called Lagrangian is invariant. Lagrangian is invariant. Lagrangian invariant also means this statement: Lagrangian equation of motion does not change. Invariant under addition of L dash, which is equal to total time derivative of f. Okay, so Lagrangian is invariant. What is the takeaway from this question is Lagrangian is invariant means equation of motion, Lagrangian equation of motion do not change. Though Lagrangian changes, equation of motion does not change. That is called Lagrangian is invariant. Okay, now what is that addition? This L dash means total time derivative of this f.
Here is the next two questions for you to practice. The question number 19 and 20. Kindly find the answer and comment your answer in the comment box. We will be discussing the same question in the next lecture.